Good morning, good afternoon, everyone. Thank you for joining. Today we have Eiso Kant, who's the founder and co-founder and CEO of Sourced. So I'm very excited to have him present today. And with that, Eiso, kick it off.
Thank you so much, Victor. So first of all, good morning and good evening to everyone, and depending on where you are in the world. You're catching me in my morning here in San Francisco. So essentially what I'll be talking about today is how Sourced is becoming the data lake, data platform for the software development lifecycle. And I'll be talking a little bit to you about what that actually means, showing you a demo of our Enterprise Edition, and also happy to, along the way, ask any questions. So there's a Q&A function. Feel free to shoot any questions through. If I don't catch them, Victor does, and I'll be sure to answer them throughout or at the end. So the agenda of today starts with talking about the challenges that we see at large enterprises. And so when I talk about large enterprises, I specifically talk about organizations that have over 1,000 developers and software engineers in them. But we see today Sourced being used at lots of different types of sizes of orgs. But you'll see today that the value of Sourced really shines with the more engineers that exist in an organization. I'll be showing you an overview and demo of the Enterprise Edition and some of those demo dashboards. I'll be talking a little bit about what makes the Enterprise Edition differently from some of our open source projects, and have time for Q&A. So let's start by talking some of the challenges that we see in industry. The first one is that most enterprise IT initiatives downright fail. And with failure, I don't just mean significantly over budget or significantly delayed. I also mean just projects that never come off the ground or never reach the success criteria that were set off on day one. And the reality is for us to spend time in enterprises, we see this constantly. Big database migrations, big new applications that get started that never get finished. And in our opinion, the root cause of that failure happens because IT leadership has a complete lack of visibility of what's happening across the software development lifecycle. So if we look at a software development lifecycle, we find lots of different tooling that we use that generate data. So it starts with the Jira tickets or the GitHub tickets or GitLab issues, where we end up writing down our business requirements, right? And our backlog from product features that match those business requirements. Then next up, we actually go write the code in the version control system. We manage that usually through Git repo and some collaboration tool on top of it, like GitHub or GitLab, etc. We then often have our CI/CD pipeline, where we use tools like build systems and automation tools like Jenkins or Circle CI to actually automate our builds. We create artifacts, can be packages, that can be jar files, virtual machines, Docker containers, and then we ship those off to the clusters that run them. And across that entire SDLC, all of these tools and ourselves as developers are generating data. That could be that we're writing new code. It could be the output from our CI system that says if our test passed or not. And so what Sourced aims to do is to take all of those data sources and make them accessible into a single data lake. And data lake is a very enterprisey word, but fundamentally what it means is all the data that comes out of this tooling lives in one place under one data model, where I can use SQL to query it and to get access to it. And that's really what Sourced aims to do. So let's talk a little bit about the Enterprise Edition and how it does this. Right. So once we have this data lake in place, the really core of it is to give everyone from an engineering manager all the way up to the CIO the ability to have observability and visibility into what's happening in the code, the teams, and processes. So I mentioned those different data sources before. The way our technology stack essentially works is that we have ingesters, collectors, and transformers for each of these data sources. For those of you who know us from the open source world, Sourced is the creator of Go-Git, one of the 3 main implementations of Git in the world. We are the creators of universal ASTs. So let's break those two down a little bit. Git in itself, Git repositories that live on our file system. We query them with when we type git commands, right? Git log, or I push to them, I change them, I check out a master branch. All of those operations are touching underneath pack files, the way that Git stores that information. And when I want to get data out of Git, I want to understand, how did the code look like 6 months ago? Or what has the changes been in the last 4 months? Who made what changes? How many lines of code have we changed? Or when did we first introduce the Prometheus as a logging library? And all of that I need to be able to get access to Git repositories. So Source adds Git repositories as a data source. And we actually have implemented SQL, SQL, the language, to directly speak to those pack files. So that's one of the transformations and data sources that we do. The other is when you deal with source code in itself is just text, right? And text in itself is not so useful. I can do some grepping, I can do some extractions on it, but what I really want is a representation that comes closer to what the compiler sees. And what the compiler first sees is an abstract syntax tree. Essentially, the ability to look at a piece of source code in a tree-like format and understanding that this piece of text means that this action is happening. This is an if statement, this is a binary operation, this is a negation, etc. This is an identifier, something we've named. So Source created universal ASTs to make that language agnostic, so that I can query things like, show me all public functions that do not have comments and count them, or give me all the import statements from all the files, etc., etc. So all of these, and this is just a couple of examples because we have a lot more data sources, a lot more transformation, but all of that data transformation happens inside Source and then becomes accessible through SQL, which I can then hook up any BI tool to or use with the BI tool that we ship, which I'll show in the demo today. So what makes Source particularly unique? What makes us different from other people? Well, there's a couple of things that make us different. The first thing that makes us different is that we've built for scale. Right? So Source is fundamentally designed to be able to process 100, 1,000, 10,000, plus even more repositories. And this comes from the fact that we come from a background of essentially running our early data engineering tools over millions of public Git repos. And the next thing that makes us different is that we were one of the first companies to start working on machine learning on code. So essentially the ability to extract insights and understand what's happening in source code using machine learning models. The main models that we work on at Sourced are related to understanding the natural language in code, right? The way we name things, the way we name variables, the way the functions are named from libraries that we import, say a lot about a piece of code. Right? When I just look at the names, it's easy for me to determine, is this something connecting to a database, or is this actually dealing with hashing something, or is this cryptography related, etc. So understanding natural language in code ends up being very useful for us to be able to get to providing you insights, because it allows us to start looking at source code and say, okay, now let's look at every developer in the organization who has experience in cryptography. Or let's look at how our own knowledge of machine learning has grown over time in the org. All of those things need machine learning models to be able to extract these things from the code and make sense of it. This is just a very small kind of sneak peek into what we do with machine learning on code. If you're interested in finding out more, definitely reach out to us, have a look at some of our GitHub repos, and I'm happy to explain more. But particularly our focus on skill and our focus on using machine learning are what set us apart. So how does this actually look like to the end user? Well, the end user of Sourced is anyone from an engineering manager to an architect, to a head of DevOps, a head of IT, all the way up to the CIO. And every single one of these users ends up seeing a different set of dashboards and metrics that they care about. Because the way that we work from our enterprise edition is that when we have a conversation with a potential client, I actually just got off a call with one, we showed them the demo that I'm about to show you. And we talked to them and said, okay, what are the major IT initiatives that you have undergoing in your company, in your enterprise, that you feel insights would hugely help you, would help you to de-risk failure, would help you to drive behavior, would help you to reduce costs or increase productivity. And from there, together with you, we work on designing the dashboard that makes most sense for you. But the cool thing about Sourced is that that data lake that we put in place, and that data model is the same for everybody. So you get directly access to that. So if you have an analyst on your team, or you're an analyst yourself, or someone who's just comfortable with SQL, you can build your own charts and your own queries. So let me give a quick example of how that looks like. So let me stop sharing here. And let me start sharing on a different screen. Give me 1 second. Okay, here we are. So what I'm showing you right now is a dashboard that was demo dashboard created for the CTO at Cloud Foundry. You yourself might care about completely different things and might want very different things showing on this dashboard, and that's what is highly possible with Sourced. So what we're looking at here is our modified version of Apache Superset, which is a popular open source BI tool created at Airbnb. Since Sourced Data Lake is an entry point with a SQL server, you can connect Tableau, Power BI, Looker, any tool that you have to it to get dashboards as well. But we recommend using Superset, and we ship and deliver with Superset for you. So let's start having a look at some of the things that we show in here. In this case, it's the number of repositories. This is a relatively small organization, 855 repos. We see big enterprises with up to 20, 30,000 repositories. An activity health index, activity metrics that were jointly determined on figuring out what is it that matters to them. Activity in this case is really around, are people closing issues? Are they responding to pull requests in time? Are they merging them? Are they leaving things actually active and in a healthy state? But activity might mean something else to you. Development speed, how fast is the throughput of our issues and the features that we're shipping. Here we're looking at a breakdown in what languages, how many files live in what languages. So we see that in their case, there's over 90,000 files in Go, 20,000 files in JavaScript. This is in head, in the master branch. We see that health score activity broken down for the top 10 largest projects. We see the evolution of commits. So we can actually see here, okay, there's clearly two very, very large projects that deal with the most commits over time. We see the throughput of issues, right? How many issues? We can see there's a big decline in the last coming months of how many issues actually were closed, but a big growth over the last couple of years. Now let's shift focus on something else, on actually behavior of engineers. So this is really around what percentage of my developers are engaging in code review. What is the average number of reviewers per code review? How much code review is happening without any comments given? So people are just approving or rejecting. How do those metrics change over time? How do people actually behave on pull requests? So we actually see that this is an organization where a large number of developers use pull requests, almost 88%. A very small number of developers actually review code, and a lot of code actually doesn't get reviewed. So while pull requests are used, in over close to 80% of the cases, actually merged without any review happening. Here we start seeing the actual time that's taken. So in this case, it's about 2.5 days from the creation of a pull request to merging. And we've seen that that's hugely changed over time. In the past, it was closer to about 10 days in the organization. And we can see here that the size of the pull request hugely matters on how long it takes to close. So a smaller pull request gets closed merged significantly faster than a larger pull request, actually about almost 4 times as fast. We can look at that as well for based on additions versus deletions. So what we actually see here is that code that is deleted gets merged much faster than code that is actually added. And this kind of makes sense, right? As developers, when we see that we delete code and everything still works and our tests still pass, we're much more likely to merge than when we're adding a huge amount of code. So the lesson to take from these two charts is make small pull requests as a developer. So let's start having a look at a few other things. Dependencies. So here what we're doing is we're doing essentially what's called a shallow dependency extraction. We're looking purely at the import statements that developers are using in code. So this doesn't look at versions. This is not so much to use as compliance, but this is really to understand what are the major technological components that we are importing across our code. So here I can see the largest dependencies, but I can also see the fastest growing external dependencies. So it turns out that actually Prometheus, that you might be aware of, the actual metrics, performance metrics kind of dashboard that you're able to use with logging, is right now the fastest growing library from the company, and the fastest declining one is Segment.io. Here what we look at is how cryptography functions are being used and called, and how often they're being called across the code base. Again, this is based on the names of those libraries and those functions. So this gives you a high-level picture of, okay, what are the main crypto libraries, what are the main functions in them being used. This is particularly useful when you're a financial institution and you need to understand, are we using a cryptography function somewhere that we shouldn't be using, right? So there's often like a list of compliance ones that you're like allowed to use and which ones you're not allowed to use. So in this case, AES, I know, for instance, is one that isn't allowed to be used in many places. And here we can find all the places where it's still being used. But I can also go and take another point of view, not of dependencies, and looking at what are the major pending bugs, what are the ones that are the major pending features that are the longest actually in age spent, the top pending pull requests that we should actually look at. Are we missing files in repositories where we should be having those files, such as the changelog or the license or the Travis CI file or the Docker file? What actually exists in those Docker files? What is the main base images that people are using? Right, so here I can see there's a lot of different base images that are being used across this organization. Ubuntu being by far the largest, but also close to, it looks like at least 8 to 10 different versions being used. And the most popular package, actually didn't surprise me much, is curl being installed. If I take it another step further and look at those Docker files, I can also go and set up rules. I can set up different rules that I care about to actually have to check in those Docker files and start building compliance scores. So what we're looking at here is misbehaving repositories where commits are not signed off, where the Docker files is not matching the best practices guide, or the blobs are actually not under the size that we recommend. So all of this is charts that are built on top of the data source. So what you see in the source data sources is you see Git base, which is essentially the ability to speak directly to your Git repos. It can take concepts like files or commits and have all of them exposed here, SQL, and I can write my queries to get access to them. Right? I can see, okay, I see Corbin Halliwell here, and if I want to see all the commits that Corbin has done, I can go, okay, select star from commits, where commit author name. Let me just pull up 100 of these. And so this is, of course, a very simple query, but I can go and make much more complex things. And what makes the Sort Enterprise Edition interesting is that I can cross-query across all these data sources. So I can do something like give me the log files from Jenkins CI that are imported into Postgres, take the commit hash from that, and find out and join it with the data that says which team people live in to find out the average team, the average time spent on builds per team, to be able to identify where we need to actually add additional resources. So, and we don't just see Git-related data sources. You'll start seeing here, there's also a lot of custom data sources that we set up, like Docker files, Docker file issues. Look here, vendors, similar code across teams, the Docker files, the imports. So all of these things end up as tables that you can query and you can access. When I mentioned earlier universal ASTs, the transformation that we do on source code, here's an example. Here on the left side, I have a piece of code in Java, and on the right side, I have that kind of what we call a semantic UAST, where I can now do things like give me all the imports. Here you can see it filters out the imports. or give me all the comments that exist in there, or give me all the functions. The nice thing is that this little query that you see here, I can combine actually with queries that I use in SQL. So if I go and take an example of this query, just open this up in SQL Lab. You'll see here that I have a query where I'm saying, give me all the Go files. Yes, Go, exclude vendor folder, only do this on head, and give me all the functions where the name starts with test, which for Go is a good way of looking at a lot of test cases. So I have a syntax error somewhere. So the idea here is really to show you that the interesting thing about Source is adding a lot of data sources across your SDLC and the ability to cross query across them. So let's jump back to the deck. Other things, by the way, that exist in here is the charts section, where you can see different charts. I'll give you an example here of, this is the one that I mentioned with most violated Docker file rules. So you see different rules that we're checking on Docker files. Use copy instead of add, use work directory to switch to a directory, use wget or curl, but not both. And you also see the ability to import dashboards, add data sources, and add users with very fine-grained user access control. So I can determine who can see what dashboard, who can query what data source. I can see logs related to who queried what. Great example of that here. And so the Enterprise Edition comes with a lot of that data present in there. So let's jump ahead a little bit. So as I mentioned, Sourced at its core is open source. We have a GitHub community that has vanity metrics like over 15,000 stars. We have over 2,500 forks of our projects. We have about 10 open source projects that are really core to what we do. The most popular ones, the most notable ones are definitely GoGit for Git, Babelfish for universal ASTs, and Gitbase for SQL on top of Git, but also projects like the awesome Machine Learning on Code list, where all the machine learning on code research is gathered. And we have over 500 members of our Slack. Today, we know that our open source is being used in the components at places like Microsoft and Apple Security, but also at smaller companies like Keybase, which use our popular GoGit library. And Gartner recently named us a cool vendor in the application development category. So how does the tech stack kind of look like for the Enterprise Edition? So the way to think about this is that there's about kind of 4 layers. And so we have here the data retrieval layer, where we have a lot of projects, more than the 4 listed here, that are responsible for accessing the data sources, pulling them in, essentially transforming them. Then we have the data analysis layer, where we do things like code duplication detection with Gemini, Babelfish with UASTs, Gitbase, which is SQL on top of GoGit, Hercules, which is a library that we use to pull out interesting Git statistics. And then on top of all those data sources and all these components, in the Enterprise Edition, we have Apache Spark that sits there, that actually is the orchestrator and the register for these data sources. And then on top of that sits an Apache Spark Thrift server that then speaks to Superset. And so all of this ends up being deployed usually on a Kubernetes cluster, but it's heavily containerized, so we can deploy it in different environments. So let's talk a little bit about why people are interested in this and what they actually want to use it for, and the different types of use cases. So we see 4 different areas where we help IT executives deal with major challenges. The first is modernization and compliance. So that has to do with the fact that you're looking to swap out a big piece of old technology. You're looking to move from COBOL to a more modern language to the cloud, moving away from, for instance, the things that you were doing on premise, to being able to get rid of the Oracle database across your organization and want to understand all the files that it exists in and all the developers that touch those files. Or I'm an architect and I want to see how my API is being used. The next thing is really around this kind of moving to the cloud and DevOps transformation, which is we're now starting to set up CI pipelines everywhere. How many of our 15,000 repositories have to set up We are behaving in an agile manner from the 5,000 developers across our organization who are actually behaving in an agile manner, and how is our progress towards their going? It's all things that can be measured. What is our engineering effectiveness? So some of those productivity metrics or the metrics related to, are we actually adhering to code review and how's that going over time? Kind of talent assessment, looking at all the skill levels that different developers have across the organization by using some of the machine learning models to pull that out. So if we break that down a little bit more, and I'll run over this in a couple of minutes, but feel free to screenshot this and I can also share it afterwards. On IT modernization and compliance, some of the things that we're able to do and deliver are things like analyzing what frameworks are being used, understanding which code is unmaintained, figuring out which percentage of your applications and technology is actually not using technology that you adhere to or want to do. How much percentage of our code is similar or duplicate? Where are we still using legacy components? How far along are we in spinning up microservices and moving towards that architecture? In terms of cloud native transformation, it's really around understanding the vendors I have, how technology is adopting, how much of applications are already adapted to the cloud and are moved towards the cloud, how many of our applications are already Dockerized versus not, where are we actually building public APIs? If we're moving towards a microservice architecture, where are we? If we look at engineering and effectiveness, it's the things that I mentioned related to engagement of people, time spent across the SDLC, and really looking at the breakdown of those metrics based on different criteria, like such as the size of a pull request or the size of a change or the individual team. And the talent assessment, it's really around how is the expertise in our company changing? How are we collaborating across the company? And where are we allocating our resources? And how does that relate to things like attrition and churn rates? So the way we work in an enterprise environment is that we always look to be benefits funded ROI. So whenever we have this discussion on this is sourced, we are a data lake for the software development lifecycle. That data lake allows you to get answers to questions you have. We work with you on designing the dashboards that are relevant for you. We work with you on determining what the metrics are that you care about most. And then we look at making sure that the metrics that we are measuring and the behavior that you're looking to drive with that can have a significant return on investment for you. And so that sometimes ends up around productivity. Sometimes it is around talent retention. It can even be on infrastructure cost optimization, such as you saw earlier, a scan of Docker files. We're now also adding a scan of Docker images this summer, where it can be the infrastructure cost that you save when you start determining the large base images that you are using and running an infrastructure where small ones can be used. So the power of Source is that we're this big data lake that allows to answer questions across a huge array of different areas. The power to you really comes from determining together with us where the measurable ROI is. And so what is different between our open source and our recently announced Source Community Edition and our Enterprise Edition? The core difference is that the Community Edition and our open source projects run on a single node, meaning that for enterprise scale, it isn't performant enough. Break that down, one of the main features that is missing from the Community Edition that sits in the Enterprise Edition is the ability to cross-join data sources. So instead of just asking the question of how much time am I spending on my builds or how much time am I taking to merge a pull request, I can actually cross-join across all those sources and understand from the applications that cost us more than $5 million a year to run on the cloud, which teams are responsible for those, and how much time are we spending on shipping new features for fixing bugs, right? So cross data source queries. Next to all of that, things that we deliver on the enterprise are related to security and compliance, supporting SLAs, training, the ability to deploy in on-premise, fully managed or self-managed, and other advanced types of analysis that might be custom to you. So this is the core of Sourced. I really want to leave the rest that you have to any questions if you have today and cover those, and I'm happy to jump back into the demo or to any previous slides. So I'll give everyone a minute to write out anything that they have in the chat, and then I'll start answering ones that either go private to Victor or in the full list here.
I think you muted Eiso, but
thank you. Sorry. As I was saying, so one of the questions that I just got in here privately was, what can you do with cost data? So when you care about attaching numbers to spend of what's running in the cloud, spend of what is the time of your engineers, those are data sources we can all hook up. And we can actually determine. So when we look at, we can make estimations of how much time was spent on a feature by looking at the actual time from the original ticket to the work that was done between commits, and quantify that when it is about what's cost of what's running in your cloud. Those are things that we can hook up and pull out of your Google Cloud, Amazon AWS account. Another question I see coming in from Carlos here is, which third-party integrations are offered in the Enterprise Edition? So in the Enterprise Edition, today we have integrations with almost all popular ticketing tools, such as the Atlassian suite, the GitLab suite, and the GitHub suite, so that's things like Jira. We have the same integrations with most popular version control tools. We support all Git repositories, but if you have SVN repositories or other formats, we help with the actual transformation of that data, provide that as well. When it comes to build systems, we integrate with the popular ones such as Jenkins, Atlassian Bamboo, and if you have a build system that we don't have yet today in place, CI/CD system, we will likely be supporting that automation soon or working on prioritizing it for clients. Next to that, so the way to think about this is today we support everything from Jira tickets up to artifacts. So the scanning of Docker images and packages. What we do not yet support is runtime analysis of what's running on the cloud. So I see Ben coming in a bit late. Is this open source? So what is open source today is the integration with Git repos and GitHub. All the other integrations that I'm mentioning are not yet open source. Some of those will become open source. Some of those will stay in the Enterprise only edition. Any other questions?
Eiso, did you see the one about how many nodes can Enterprise Edition utilize efficiently?
No, I don't. I think
not
it might have come just to you. No worries. So yeah, so it's sourced skills essentially with size of your data. So we today ourselves run some very, very large clusters of sourced, or for instance, over all the GitHub repos above 50 stars, which is usually close to 2 magnitudes larger data than you would find even in the biggest enterprises. So sourced skills well. It is purely scaling horizontally by adding on more data sources. So seeing Carlos's next question, does deployment options mean deployment of sourced or analysis of the deployments made by the company? What kind of analysis there for CI/CD? Yeah, so deployment options in this specific slide that I showed you before was actually related to that we can deploy on-premise, managed or unmanaged. But yes, we pull in CI/CD. What we do there is any metrics that you're interested in getting insights on based on your CI system, like Jenkins, we can provide. So there's 2 types of data that we pull in there. One is the log files that come out directly, and the other is the API data that these tools provide. So in the API data, you can find things like, did the build pass or did it fill? How much time was spent on it? When was it initiated? From the log files, I can pull out extractions that go much more in depth. Test coverage, for instance, pulling that out of there is one of them. The best way of understanding if we can help you with something is to really come with a list of, hey, this is what I would love to know about my CI system in this case. We can tell you if it's possible to measure that, and if it is possible, it either exists in Sourced or we are ready to work on adding that to Sourced. We are 40 people today, and almost a big part of our work goes towards constantly adding the ability to answer more questions. Any other questions or questions that weren't answered fully that you'd like some more insights on? See one more coming in. So HR systems. So I mentioned earlier that we pull in data from HR systems and are willing to make those integrations work. And so the way to look at that is that when you're getting all this data, often you want to look at it for just a specific business unit, a business area, a specific team. Sometimes your organization is very well modeled in GitHub Enterprise or in Bitbucket or GitLab. In many cases, we see that the organization isn't yet properly modeled in there. And then it makes a lot of sense to actually integrate with something like Workday or the Oracle Suite and pull out that data. And for that, we are willing to offer support. In terms of, so Luis's question, in terms of individual contributor contributions, does the machine learning offer more direct value? Like, does it make intelligent suggestions on PRs? So we have research projects and community projects that are working on this. You can have a look at Sourced Lookout, where we've been working on machine learning based analyzers for things like style suggestion and integration of others. Today in the Enterprise Edition, we don't give anything valuable yet to individual contributors. What we do see with ICs is that people use it for an advanced way of searching how code is being used and where code lives. So queries like, how is this API being, this specific function name call being used across the code base? But we do not do kind of CI level integration yet, like on automatic pull requests. Ben's question, can you speak to any capabilities for being able to validate libraries, etc.? Yes, so one of the nice things with Sourced is that we keep building up more capabilities for dependency analysis. So as I mentioned, dependency analysis can be looked at in several ways. One is the extraction of what is being imported in files. The next thing is the dependencies that live in package files, like manifest files and POM files and requirements.txt, like in Python and others, and extraction from that. And then the third level is really understanding what is being built. Today, for different languages, we have different amounts of support for how much we can pull out from dependencies. So it really depends on your specific use case, but dependencies are becoming a first-class data source of Sourced, so that you are able to query things like, in this repository, what version of what dependencies live, or in this Docker file, what actually are the packages that we're importing, in this Docker image, what are the packages that are already installed. So we constantly are working towards increasing those capabilities, and we prioritize them really on what we see our clients need. So if you have specific requirements for understanding versions of libraries in a certain language or a certain group of libraries to understand, that's where we go in and we make sure we prioritize. Yeah, so Carlos has a very nice question. It says, what if I see a giant and constant increase of the calls to a certain database? Is it possible to see something related, like who is committing the code related to these calls? Yes, that's actually what makes Sourced valuable and what makes the Enterprise Edition really cool, in my opinion, is that being able to cross-query across those things is exactly possible. So I can go and now say, let's scan all the commits, let's take the UAST from the files that are referenced in those commits, let's find out if a call to a certain database is happening in those commits, and now group that on a count of files edited by author. And so I can go and see who are the people who've mainly been adding new calls or editing them in files related to calling this MongoDB function in Java. So absolutely possible. Any other questions? I'll give it a couple more seconds. I see one coming in. Yes, Carlos has one more question. Go ahead, Carlos. Is this connected to natural language? So the way to look at natural language in source code is, let me start with a fact that I found really interesting. So if you look at a piece of natural language, and if you look at code without natural language, right, we take all the variables, all the things that we have as humans have named, function calls, etc., and we replace that with A, B, C, D, 1, 2, 3, code becomes completely useless. I cannot understand what this code is trying to do. I'll be able to see, okay, here's a loop, or here is like, like there's certain structures I'll be able to identify. But the reality is that code without natural language is fundamentally impossible to understand. So a lot of this does have to do with natural language, but there's different types of natural language to look at. There's the things that we've chosen to name ourselves, right? The way we've named functions or variables. There's the things others have chosen to name for us. Like library, like functions in libraries. And then there's natural language that exists in like comments or other things. I see that you're clarifying your question. For instance, a query that understands database and relates it to variables, database con, MyDB. Yes, absolutely. So we are actually doing a lot of work on this right now. We've done already, there's already some papers out that we have in source related to word vectors, code vectors, where we actually understand that, okay, database and database connection and MyDB and connect database are actually clustered very near each other and talking about the same thing. We do not have that exposed yet in our query API in SQL, but that will definitely be coming soon because that research has already been completed, and I know it's worked incredibly well, particularly for things that are very obviously related to each other, like the database identifiers or cryptography identifiers or identifiers related to a certain part of the system, like the cache checking of a system or like something business related. This works very well. And it's something you can expect in the future to see in the SQL API of Source. Any other questions, anybody? Well, then, thank you so much. I really appreciate everyone's time. I hope this was informative and gave you good insight into Sourced and what we're doing with the Enterprise Edition. We are always happy to have longer conversations. We're always happy to speak to anybody, to do individual calls, or to give you a walkthrough, or to let you get access to a demo instance to play with. So please reach out to us if you have any of these ideas or questions. And thank you everyone for your time. And this was actually one of my first one that I'm doing. So I hope it was useful and look forward to doing this more often in the future.
Awesome. Thank you, Eiso. And we'll make sure to share the recording very shortly.